Are you having trouble factoring polynomials, specifically some of those ugly looking quadratic trinomials, and maybe even some of those cubic polynomials? Stay tuned and I'll give you a couple of tricks to get you started. Hey there, sports fans. Welcome to Planet Numeracy. If we're just meeting, my name is Mark Nolde. I have been teaching high school and college students how to do math for over 20 years now, and that includes my 4 daughters. So stay tuned for some quick tricks on how to factor polynomials. All right, so here's our factoring polynomials here. These are trinomials, and they kind of come in 2 flavors. One where this is positive, and one where the constant term is negative. So depending on how we're looking at it, we're either looking for factors of this number that have a difference of this number, or this one, factors of 12 that add up to 7. So the factors of 12 that add up to 7 are, well, they're 3 and 4, but if you need to, go ahead and jot down the factors of 12. So that would give me 1 and 12, 2 and 6, 3 and 4, right? So we've done that before. So if this factors, or it does factor, or else I wouldn't put them on this video, it's going to look like this. These will both be pluses, and the 3 times 4, that 3 plus 4 is what adds up to 7. And the way we check this, if you recall, x times x is x squared. My outers add up to 4x, my inners are 3x, so 4x plus 3x is 7x, and 3 times 4, that's 12. All right. Let's look at one more that has a plus sign here, but my linear term, my x term, is going to be negative. So we're going to scroll down the page here. I have one set up for you. So again, we're looking for factors of 30 that add up to 11. Only this time, instead of both of them being positive, these are both going to be negative. So x minus and x minus. So this one's still a little bit easier because you're looking for factors who add up to something, not whose difference is something. So those would be 6 and 5, correct? If you have to, go ahead, write down what are the factors of 30. But for these ones where it's a plus sign, they're usually not as tricky. But go ahead and write them down if you want to. That may be helpful. All right, now let's look at the same as the one above. FOIL it to check it, x squared. Outside, negative 5x, inside, negative 6x. So adds up to negative 11x, and negative 6 times negative 5 is positive 30. Maybe that looks like a minus sign. Let me just remove that. There we go. All right, now let's look at ones that are sometimes a little bit trickier for students. Right, here is, if this is going to factor, it's going to look like this. But because this term is negative, one of these factors is going to have a plus sign and one is going to have a minus sign. So let's go and put a plus and a minus in there. So what are the factors of 5, in this case, whose difference, because that's a minus sign, whose difference is 4? Well, there's only 2 factors of 5, and that is 1 and 5. So, but the question is, where does the 1 go? Does it go here? Or does it go here? So what controls that is this. So because this is positive, the big number, the 5, will go with the positive. So that's one of the easiest ways to remember that. So let's put that in there. And again, double check it. First times first, x squared. Outers, minus 1x, inners, 5x. So minus 1 and 5 is 4. And then last times last. Positive 5 times negative 1, there's your negative 5. So this one checks out. We'll look at one more where we have a minus here, but also a minus here. And that is down here. So if this factors, or when it factors, we're going to have x and x here. So we're looking for factors of 15 whose difference is 2. So let's write down the factor sets of 15. Got 1 and 15. And let's see, just 3 and 5. Those are the only 2 pairs. So of these 2 pairs of numbers, these have a difference of 14. These have a difference of 2. So that's what we're looking for. So just like the other that had a minus here, we got to get a minus Whoopsie. Got to get a plus and a minus here. So again, we're using these two numbers, and what is going to control where the 5 goes is this, the minus. So the big number, the 5, goes with the minus over here. So we go ahead and we jot that in there. And just like before, if you want to, you can check it. First times first, x squared. Outers, minus 5x, inners, 3x. So minus 5 and 3 is minus 2. And last times last, positive 3 times minus 5 gives us the minus 15 here. So that one checks. Okay, this will stymie even some of the best students. The reason being is my leading coefficient here is not a unit anymore. So what do we do when we have an 8? Well, the hard way to do it would be to say, well, I could have an 8x times an x, and then one would be a plus, and one would be a minus, or this could be a minus, or this could be a plus. So there's a lot of different possibilities there. 4 and 2 are also possibilities for being multiplied by 8. This could be plus or minus, and this could be minus or plus. And that's because my constant term is negative. So I have to multiply a negative times a positive to make this be a negative. So here's a little trick somebody taught me. I don't remember who. But when you see these problems, multiply that last number, the 15, multiply it by the 8. So that would give me, let's see, x squared minus 14x minus 120. All right. So notice this isn't the same problem as this one's not the same problem as this one. But there's a little trick that we're going to do here. What we've done now is we made a problem that's easier to factor because we have a leading coefficient of 1. So we have to find factors of 120 whose difference is 14. So start by writing down, I guess, the factors of 120. I'll do it in a different color here. Well, it's not going to be these. 1 and 120. 2 and 60. Could be 3. Whoops, I put that on erase. 3. And 40. Could be 4, 30. Let's see, 1, 2, 5, 2, 24. So 5 goes into 120, 24 times. We're getting closer. So this is 6 times 20. Okay, so these have a difference of 14. All right, so I found the two numbers I need. Difference of 14. So I'm going to come back up here and go x and x. I know one has to be plus and one has to be minus. And remember, the bigger of the two numbers, 20 and 6, is going to go with the minus over here. So go ahead, we're going to put our 20 here and our 6 here. So notice up front what we did was we multiplied by 8 here. So we're going to divide that 8 back out. So I'm just going to say divided by 8, divided by 8. And then the trick is to reduce these fractions, 6/8 and 20/8. So 6/8, let's see, I could have an x, and that would be what, 3/4? And let's see, 20/8, that would become what, 5 halves? So x minus 5 halves. So that's an important part. You have to reduce these. Okay, for this trick to work, you have to reduce them. Then all we do is we move this 4 back up front where it was. Put a 4 up there, and I'll put a 2 right there. So that gives us 4x plus 3. So this 4 is gone now because I put it here. And then I'd have 2x minus 5. And then this 2 is gone now because we put it right here. So that's it. Now we're done. We didn't have to do anything too complicated there. But we can check it. 4x times 2x, 8x squared, minus 20 and plus 6x is the minus 14x. And 3 times minus 5, that's our minus 15. So I thought that was kind of cool the first time that I ever saw it. So let's look at one more just for good measure here. Okay. All right, here we go again. Let's bring this 6. Whoops, let me do a different color. Let's bring this 6 over. So multiplying by 6. That changes this to something that I'm going to be working with. 11n minus Oh boy, sometimes these become harder than they needed to be. But just because we're working these problems out, we'll go ahead and come up with the factors of, different color please, yes, the factors of, I guess it would be 1 times 126, or 2 times 63, or 3 times 42, let's see, 4, no, 5, no, 6, I know 6 goes into it because 2 and 3 go into it, but still no difference of 11. So 7 and 18. Yep, 7 and 18. So I have to try to factor this now. N, and I need a plus and I need a minus because of this minus sign. But this plus sign is going to tell me where the big number goes. So 18 and 7. So the next step was, remember, we first multiplied by 6. So now we're going to divide by that 6. I'm just going to divide that back out. All right, and we need to, when possible, let's see, make this into a reduced fraction. All right, 7/6 is already reduced. So now remember, we move this back out in front of the leading term. So we just have n plus 3 times 6n minus 7. So we can go ahead and check it. N times 6n, 6n squared. Outers, negative 7n. Inners, negative 18n. So 18 and negative 7 is positive 11. Last times last. That's a plus 3 times a minus 7. So yeah, that gives us a minus 21. So that works out quite nicely. Okay, now we're going to try to factor some cubics. So we have a third degree here. So the first thing we always try to do before we would do polynomial long division or before we would do synthetic division is to see if we can use a factoring technique. So this is just a refresher on those factoring techniques. So what I'm looking at is the leading terms here, because I'm going to try to make both of these look the same. So I have a 1 and a 4 here. So let's see, looking at this first one, 4 divided by 1, second one, 4 divided by 1. So when these numbers are the same, that means it lends itself to being factored using grouping. So here's how we would go and group them. So I'm going to remove this, just give a little erase there. So I'm going to factor out from this section the greatest common factor of x squared. So what's left is x plus 4. And over here, we're going to factor out, well, there's nothing to factor out. It's already x plus 4. So notice I now have a common factor of x plus 4 that I can factor out, or think of it as undistributing. And what's remaining is x squared. And here's a common blunder. There's a 1 here. So there's still a 1 left over here. So that's why I put that in a different color. Very common mistake to make, to forget that. But I know you'll do it right. Okay, so that's it. We can't factor that one any further. Do I have another one? Okay, yeah, here's one. Okay, again, I set these all up so that this divided by this equaled this divided by this. So 1 divided by 3, negative 1 divided by 3, that's a negative 1/3. I'm going to write that down. And over here, we're looking at negative 2 divided by 6. So negative 2 divided by 6. Well, that reduces to negative 1/3. So again, this number matches this number, so I know that it lends itself to grouping. So I'm going to group here and group here. So factor out my x squared, because that's the greatest common factor of those two terms. If I do that, I have remaining 3x minus 1, because x squared times 3x, easy enough. But this is one of those blunders that's easy to make. X squared times 1 is x squared. So we have to put this 1 in here. Over here, the greatest common factor is, well, let's see, a 6. No, a 2. So I'm going to factor out a 2. and that leaves 3x minus 1. So by these two being the same, it makes these two be the same. So now we have something to factor out. Okay? And remaining is, switch colors again, remaining is x squared plus 2. And that does not factor any further, so that's your final answer. Do I have one a little more tricky? Yeah, I got one more on here. Okay. Again, what is negative 6 over 3? That's this negative 6 over 3. That's a negative 2. And then I have 18 over negative 9. So I'm going to write 18 over negative 9, which also equals a negative 2. So that tells me I'm going to be able to factor out and have an x minus 2. So in this first section, I'm going to factor out a 3x squared. So that leaves me, when I factor 3x squared out, I have an x. And a 3x squared factored from here is a minus 2. And then over here, the greatest common factor is negative 9. So that's going to leave us with an x and a negative 2. Because remember, negative 9, if I try to put this back out, negative 9 times x, that's negative 9x, and negative 9 times negative 2 is 18. So, looks pretty good so far. Then, common factor comes out, x minus 2, and then we have 3x squared minus 9 remaining. But, notice 3 and 9 both have a common factor of 3. So that can come way out front like this. And if I factor a 3 from here, I would just have x squared left. And if I factored a 3 from here, I would have a minus 3 left. So 3, none of that factors. So we are done. That's as far as this factors. Sometimes we have to pay attention. These could go even further. Let me see if I can find one that goes even further for us. So here is one where it factors further again. But first, do our test. I have 3 divided by 1. Let's see if it lends itself to this. Negative 12 divided by negative 4. So that's negative 12 over negative 4, 3. So this number matches this number, so that means I'm going to have an x plus 3. So let's factor out my greatest common factor right here, which would be x squared. And that leaves me with, let's see, x plus 3. So double checking that, we have, look at my pointer, x squared times x cubed, x squared times 3, 3x. All right, good. Now let's come over to this side. Greatest common factor of negative 4 and 12 is, well, negative 4. So I'm going to put this here. And that means I have an x plus 3. Remember, we knew we were going to have a plus 3 left over. And I'm going to double check or show you to make sure. What's negative 4 times x? That's our negative 4x. And what's negative 4 times 3? Well, that's a negative 12. So let's factor out x plus 3. That's our greatest common factor. And the factors that are left over are x squared and minus 4. But, look there, that's the difference of two perfect squares. So we could keep on factoring. So if the problem says to completely factor, we want to make sure we completely factor. And we hopefully remember from algebra class that when we have the difference of two squares, it factors into the product of the sum and difference of two numbers. And those numbers are x and 2, the square roots. Okay, so I hope you got some value out of that. Let me know in the comments down below which ones are the most tricky for you. I can try to make more videos on them. But as always, remember that math is not a spectator sport. You have to practice it in order to get good at it. So if you did get some value out of this, I'd appreciate it if you hit the like button and maybe even subscribe. Also, you can share these with somebody who you think might be needing some help on them. So this is Mark Nolde signing out until the next one.